Hi, welcome to iFlip for Math Mathcast, Lesson 4-8, Prime and Composite Numbers. My name is Mrs. Gooding, and our quote today is by Vincent van Gogh. He said, "If you hear a voice within you saying you cannot paint, then by all means paint, and that voice will be silenced." I kind of feel the same way about math. If you have a voice inside of you saying you're not good at math, then do math, and that voice will be silenced. You'll start feeling a lot better about your math. Our learning goal tonight is to identify prime and composite numbers and use prime factorization. So our individual lesson learning goals are to identify prime numbers, to identify composite numbers, and to show the prime factorization of a number. And those are that's a painting of Van Gogh and a painting by Van Gogh. Here is our vocabulary for tonight. A prime number, you are really going to want to remember this. A prime number is a number that has exactly two factors. One is one of the factors, and the number itself is another factor. So for example, the number 3 is a prime number. It has a factor of 1 and 3. 1 times 3 is 3. A composite number is a number that has more than two factors, like the number 6, which has a factor of 1 and 6, but also 2 and 3. So it has 4 factors. It has more than 2. It's composite. If you know what composite wood is, it's made up of a lot of different particles, and so that might be a way you can remember that a composite means more than 2. Prime factorization is when you break a number down until its prime factors are found. And there are two main methods that we use to do that. One of them is a factor tree, which you probably did in 4th grade. The one we're going to use tonight is called making a cake, and you'll see kind of what that's going to look like. Again, it's something a little crazy. You know we always do things the crazy way. Here's our example. We want to find out if 15 is prime or composite. So we're going to use our strategy. So I wanted to remind you of how you used a factor tree first to do this. And it's just breaking it down until you have its prime factors. So if we were trying to think of numbers that you could multiply together to get 15, we know that we can multiply together 3 and 5. And when we look at these, when we break them down, the only way to break them down even further would be to say 3 times 1 or 5 times 1. But 1 is not a prime number. It's a special number because it only has one factor, the number 1. So we don't want to list 1 in our prime factorization. So this would be the prime factorization, 3 times 5. When we make a cake, we're going to start a little bit lower. On a tree, we work our way down, but on a cake, we work our way up. We're going to look at our list of prime numbers. So we start out with 2, 3, 5, 7, 9, 11. That's as high as we're going to go for now. So we're going to use the smallest prime number that we can to divide evenly into 15. And in that case, 2 won't divide evenly into 15, but 3 will. So we're going to use 3. So now we just do like a mini division problem. 3 goes into 15 5 times. Now, this is the bottom layer of our cake. Picture a wedding cake. We're going to work our way up now. What number will divide evenly into 5? 2 will not, 3 will not, but 5 will. So we write a 5 right here on the next layer. And now we do our division problem again. 5 goes into 5 one time. When we get to the 1 on top of the cake, it's almost like the candle on top of the cake. Well, I guess it's more of a birthday cake than a wedding cake. If we have a lot of layers, it would look like a wedding cake, but it's more of a birthday cake strategy for this. So we've got our birthday candle on top, and we've got our prime factorization up the side. We don't count that 1 on top. Remember, it's not a prime number, but these are prime numbers, so the prime factorization for 15 would be 3 times 5. And we're done. It's that easy. We can do bigger numbers too, and we'll try some of those now. Here's our first problem. We're going to identify the number as prime or composite, and then find the prime factorization. We really didn't do that before, but we're going to do that now. So here we go. First, go ahead and find the prime factorization of 23. And then try and decide if you think it's prime or composite based on those definitions we talked about. Remember, prime means it has exactly 2 factors, and that's it, no more. Composite means it has more than 2. So find the prime factorization, then push play when you're ready. Did you write that the number was prime because it only has 2 factors, 1 and 23? Let me show you why that is. So I went ahead and put 23 in the lowest layer of our birthday cake over here. And then I went ahead and started writing prime numbers starting at the lowest end of it. So we started with 2, and 2 will not divide into 23 evenly. 3 will not, 5 will not, 7 will not, 9 will not, 11 will not. I've got to keep going on this list. 13 won't. 15 is not a prime number, so we've got to cross that out. Let's see. 14 is not a prime number. 15 is not. 16 is not. 17 is. 18 is not. 19 is. 20 is not. 21 is not. 22 is not. But 23 is. So the lowest prime number that will divide evenly into 23 is 23. 23 goes into 23 one time. And remember, when we've got that birthday candle on top of the cake, we're done. There's only 2 factors in 23. 1 times 23, so it's a prime number. It has exactly 2 factors. Let's try another one. Number 2. Let's find the prime factorization for 27 and see if it's prime or composite. Go ahead and write both of those things down and push play when you're ready. Did you write composite? The prime factorization is 3 times 3 times 3. Let's see how we did that. So I wrote 27 in the bottom layer of our birthday cake, and I've already listed out all of the lowest prime numbers so that we can use them. It's kind of our prime number bank. And I'm going to see what's the lowest prime number that will divide evenly into 27. 2 won't because 27 is not an even number. 3 will because 2 plus 7 is 9. And remember, when the digital root is 3, 6, or 9, we know it's divisible by 3. So we'll put a 3 right here. Now we just divide it. 3 goes into 27 9 times. Now we're going to make another birthday cake layer. And we have to find the lowest prime number that will divide evenly into 9. So 2 won't, 3 will again. So let's use 3. Now we're going to divide again. 3 goes into 9 3 times. We're not to our birthday candle yet, so we have to make another layer to our cake. This is a great birthday cake. And find the lowest prime number that will divide evenly into 3. 2 won't, 3 will. So 3 goes into 3 one time. There's our birthday candle. Now remember that 1 isn't a prime number, so we're not going to include it in our prime factorization, but we're going to include all of these numbers up the side. So we've got 3 times 3 times 3 is the prime factorization for 27. And because we have all of these numbers that you can multiply together to get 27, 3 times 1 is 27 times 1 is 27. And 3 times 9 is 27. So we know that it's a composite number. It's made up of more than 2 factors, and we can tell that just by how many layers we have on the cake. Number 3, find the prime factorization for 24 and identify it as prime or composite. Push play when you're ready. Did you write that it's composite and that its prime factorization is 2 times 2 times 2 times 3? Now your numbers might have been in a different order. You might have had 3 times 2 times 2 times 2, or 3 times 2 times 2 times 2. Well, those are the same. Anyway, you might have mixed all those up, and it's okay. Let's see how we did it. When I'm doing this, I like to make sure that I go in a very sequential order. So I'm going to make sure that I find the lowest prime number first that will divide into 24. There are 2 there, but I'm going to use the lowest one. So I'm going to use the 2. I know 2 will divide into 24 because it's an even number. So I'm going to use 2 here. Now I'm going to divide. 2 goes into 24 12 times. And I'm going to keep going. Put another layer on my birthday cake and find the lowest number that will go into 12. So again, 2 is the lowest number. 3 would also divide evenly into 12, but 2 is a lower number, so we're going to go with 2. 2 goes into 12 6 times. Again, we don't have a candle on top. We got to keep going. 3 would divide into 6 evenly, but 2 is a lower number, so we're going to use 2. 2 goes into 6 3 times. This is the best birthday cake ever. What number will divide evenly into 3? And the lowest number is 3. 3 goes into 3 1 time. Got our birthday candle on top, and we've got our prime factorization right up the side, and it's in the same order that we listed it. 2 times 2 times 2 times 3, because we always started with the lowest prime number. And we know that 24 is a composite number because of all those layers on the cake, and because we know that 1 and 24 are a factor pair of 24, 2 and 12, 3 and 8, 4 and 6. So it has lots of factors, definitely more than 2. Here, it's time to challenge yourself. Our challenge problem is totally different than what we're used to doing, but I think that you're going to have fun with it. Eratosthenes was a guy who was born in Cyrene, which is where Libya is now. We've been hearing about Libya in the news, so you may have an idea of where it's located. He lived about 230 BC, and that is over 2,000 years ago. He developed a method for deciding if a number is prime. It's called the sieve of Eratosthenes, after himself, because it strains out prime numbers from other numbers. A sieve is used to strain things like pasta. We're going to use a hundreds chart. You can print one off the website to find all of the prime numbers between 1 and 100. And then you're going to come back tomorrow and check to see if you have listed the same 25 prime numbers that Eratosthenes found. So follow those directions. They should be pretty obvious. If they say cross out every second number, then that's every other number after the 2 that you circled, or the 3. So have some fun with that. Finishing up, I just love, this is my very, very favorite Van Gogh painting, and that's a picture of him when he was very young. Review your learning goals. I know this is a little bit tricky too. Again, it's something totally new. We're doing lots of brand new lessons. That's what's so exciting and fun about 5th grade. Go ahead and write down in your journal whether you feel like you're at a level 1, 2, or 3 in your learning, and write down any questions that you might have. And you have completed lesson 4-8, prime and composite numbers. I can't wait to see you tomorrow.